This is a CS209 and we are continuing from where we stopped in the last class, tabulation and graphical representation of data. This is the part 2. So who can remind me what we covered in the last class? Who can remind me what we covered in the last class? Anybody? Okay, so we covered tabulation of data. We also covered presentation of data. So today we are going to be looking at the graphical, or in this case, we are going to call it diagrammatic presentation. So whereas tabular had to do with tables, the graphical aspect is going to do with diagrams. So introduction, the diagrammatic presentation of data gives an immediate understanding of the real situation to be defined by the data in comparison to the tabular presentation of data or textual representations. It translates the highly complex ideas included in numbers into a more concrete and quickly understandable form pretty effectively. Diagrams may be less certain, but are much more efficient than tables in displaying data. I go over that again. Diagrams may be less certain. Sorry. Diagrams may be less certain, but are much more efficient than tables in displaying data. So there are many kinds of diagrams in general use. Amongst them, the significant ones are the following. 1, we have geometric diagram. 2, we have frequency diagram. And 3, we have arithmetic line graph. So let's start with geometric diagram. A geometric diagram is a visual representation using points, lines, shapes like triangles, circles, polygons, and symbols to illustrate geometric concepts, properties, and relationships, helping explain mathematical ideas, constructions, or patterns with features like labels, angle arcs, and hash marks for congruent sides. These diagrams use specific notations, e.g. box for right angles, arrows for lines raised, and can range from simple sketches to complex vector graphics used in education, science, and design. Trust me, we're going to cover all of this. You'll see visual representation of all this, because this class has to do with diagrams and graphical representation. So we'll be looking at a lot of visuals. So now, types and uses. Basic shapes, circles, squares, triangles, pentagons, hexagons, etc. are often shown in tables. Constructions, diagrams showing how to draw shapes or bisect lines using compass and ruler. Patterns, visualizing sequences like matchstick patterns showing growth. Data visualization, geometric shapes are used in infographics and charts. Software tools, digital tools allow for easy creation, manipulation where you resize or rotate, and customization of geometric diagrams. How they help? They clarify complex mathematical concepts for students and teachers. They serve as sketches for solving geometric construction problems, and they provide visual foundations for art, design, and technology concepts. So let's look at some examples of geometric representation. So as you can see, we have this triangle here. We have this shape, if I'm not mistaken, is this a parallelogram? We have this other one. We have this, I think it's what they call a frustum, and so on and so forth. We have a sphere, we have a cylinder, we have a circle, and so on and so forth. This is a cone. So this is another geometric diagram. If you remember from what we read earlier, they mentioned how you can use you can actually use what you have in your compass, like let me see if I can go back to what they said. you can use things like compass, ruler, and those other tools to draw shapes and bisect lines and all that. So this applies to that. As you can see, a lot of this thing can be drawn using, the tools in your math set. So this is an equilateral triangle. This is square. It's a equilateral triangle is a triangle that all the sides are equal. I can't find an equilateral triangle here. I'm not sure these labelings are correct. So. But anyway, you get the point. This is a geometric diagram. I'm not sure these labelings are correct because a pentagon that I know has 5 sides. But this I think does better justice. So as you can see a lot of shapes here. Don't let these shapes scare you away. A lot of these things are constructed using geometric diagrams. While this is like a more advanced case. So before I speak to this, let me go back to something that we said earlier. They said they can be used in what? Infographics and charts. So as you can see, this is like a more advanced form of what we have been looking at earlier. This one is even 3D in nature, this one, and so on and so forth. But you get the idea when you see some very, very technical diagrams like this. That's geometric diagram in action. So now frequency diagram. A frequency diagram usually represents how often data points occur using bars or lines to show frequency counts for different categories or numerical ranges, with common types including bar charts, histogram, which is used for continuous group data with touching bars, and frequency polygons connecting midpoints of bars. These diagrams help quickly to see patterns, trends, and distribution of data, making them useful for comparing counts or understanding numerical spread. Now, types of frequency diagrams include bar charts or bar diagram. You can use any of the two interchangeably, which uses bars of equal width with gaps between them for categorical data or discrete numerical data, e.g., number of children per household. While histogram, similar to a bar chart, but the bars will touch each other, represents continuous group data, e.g., age groups, time taking, and so on and so forth. So let me just do a little explanation before we go forward. For bar chart, you are dealing with discrete data. That's something that is easily countable, like, oh, how many children in the household? 10, 5. While histogram has to do with continuous data, which is usually way more than discrete. So in this case, as you can see, you are seeing age groups. So if you're looking at the age groups in Nigeria alone, we are over 200 million. That's a lot of data. So time taken too is continuous because, time never ends. So as you can see, that's like a big difference between a discrete data that is always easily countable. So we have frequency polygon, which is created by connecting the midpoints of the tops of histogram bars with lines. I will show you all of this also. We're just doing the textual. This is the textual aspect. We'll go into the graphical aspect in a time not too long from now. So useful for comparing multiple data sets. We have cumulative frequency graph ogive, which shows the total count cumulative frequency up to a certain value used to find medians and quartiles. Now, when do we use them? When do we use frequency diagram? We use it for categorical data. We use bar charts, e.g., for favorite colors. We use it for discrete numerical data. We use bar charts, e.g., number of goals scored. I use it for continuous numerical data, which are grouped, and we use histograms for that, or frequency polygons, e.g., heights and test scores. So this is an example of a frequency diagram. As you can see, the interval is 20, 40 to 60, 80. So that's difference of 20 per interval. So looking at this diagram, what can we say is the highest point on this frequency diagram? I know the y-axis is not labeled, but even as it is like this, what can we say is the highest point? I expect an answer. That shouldn't take us time. This is a very easy question.
25, sir.
Thank you. So what is the lowest point in this graph?
3.
5.
3.
5. 3 now, because if you are counting this as 1, 2, 3, 4, 5, this corresponds with 3. So 3 is correct. So let's look at this other example. We have handspan 14, 16, 18, 20. Who can tell me the interval between each class?
2. 2, sir.
2, right? Because 14 plus 2 is 16, 16 plus 2 is 18, 18 plus 2 is 20, and so on and so forth. So in this case, what is the highest point?
12.
What can we say is the second highest point?
11.
9.
Who said 9? Can't be 9 now.
11.
11, because 11 is the midpoint between 10 and 12. So it shows that you guys are following. So let's look at this other example. You know, like in Nigeria that is in the tropical zone, we usually just have rainy and sunny season, dry season and rainy season. In the northern hemisphere, countries like America, Europe, and so on and so forth, they have spring, summer, autumn, and winter. So now looking at this table, which one can we say is more frequently occurring? What number of days are more, should I say,
Summer.
wait now, you never allow me finish asking my question. And please, other people should also answer. It should not be only one person.
Summer.
So if you notice, it's summer because summer has how many days? About, let's say, not
About
17.
like
17.
17.
but like 16 points, let's say 8 or thereabouts.
Yes.
So which season has the least occurring number of days?
Winter.
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 So as you can see, these are different examples of. Now, who can tell me which one of this? If this is number 1, if this is number 2, if this is number 3, and if this is number 4, who can tell me which one is a histogram here? 1, 2, 3, or 4?
Number 2.
Why is it number 2?
Because they are together. Because it's continuous.
Sorry?
Joint
Because
bars.
it's continuous.
Because it's joint bars is the correct answer. So
Please come again.
yeah, the bars are joined together. If they are not joined together, then that's you have a bar chart.
Okay.
So let's move on to arithmetic line graph. An arithmetic line graph, also known as the time series graph, plus numerical data points over a continuous period like days, months, or years on a grid, connecting them with lines to show trends. You guys should mute your mic. You only unmute when you want to answer questions. So also known as the time series graph, plots numerical data points over a continuous period like days, months, or years on a grid, connecting them with lines to show trends, fluctuations, and patterns in the variable being measured, typically with time on the x-axis and values on the y-axis, making it ideal for visualizing changes over time like sales or temperature. How it works: identifying data. You need data for a variable, e.g. rainfall, stock prices, over several time points, e.g. years, months, and so on and so forth. Now, plot points. You mark the value on the y-axis corresponding to the time on the x-axis. The same way on our other graph, we're able to mark how many days corresponded to the time of the seasons of the year. In that our other example. Now you connect points where you draw lines between consecutive points to show the movement of the variable, which we also did, and that's why it was easy for us to pinpoint what is the highest occurring value and what is the least occurring value and what is the second most highest occurring value, and so on and so forth. Is the points you can use to locate that. Now, types. We have single line graph, which shows one variable over time, and we have multiple line graph, which shows 2 or more variables on the same graph for comparison, e.g. rainfall in two cities. Now, when to use it? We use an arithmetic line graph when you want to see how something changes over time, making it easy to spot growth, decline, or cyclical patterns at a glance. So if you remember, what are the 2 examples? Single line graph and multiple line graph. So who can tell me what type this is?
Multiple line graph.
Why is
Multiple line graph.
Why is it multiple line graph?
You have more than one
There are
line.
2 lines.
So now, as you can see, city 1 is represented by this orange line, and city 2 is represented by this, I don't even know what color this is, but let me just call it pink. I know they usually know exact color names, but let's just call the second one pink. So now if you observe these 2 cities now, which one can we say has on average more rainfall than the other? Is this city 1 or city 2?
City 1.
51.
City 1, right?
Yeah.
So which month in city 2 had the least amount of rainfall in city 2? What month?
In July.
July.
That's actually
July.
That's actually correct. So what month in City 1 had the second highest amount of rainfall? What month in City 1 had the second
November.
It's like it's only one person that is talking, or more people should contribute to. So the answer is
November.
actually November. That's correct.
November.
So who can tell me what type of arithmetic line graph this is?
Singular.
Single, right? That's actually
Single
correct.
line graph.
Yeah. Why is it single line graph? Because there's only one line, right?
Yes.
Yeah. So as you can see, this is how to label it. We have a line, we have another line, we have points, we have the axis, this is the x-axis and this is the y-axis, and we have the parameters. In the last, not the last example, but the example for the last example, we had what? Months, and we had the amount of rainfall on the other side. Then you can have a label to label what you are plotting. So this is just like a template for plotting the line graphs under arithmetic line graph. So this is another example. So this one is compared side by side. So the blue one is actually the trend, while the purple line is actually the actual plotted value. So in this case, we have production in tons, and we actually don't have the value for the x-axis, but this is just another example to show you how another way they can plot arithmetic line graph. As you can see, in this case, you have the actual plotted line, and you have the trend of how the line is going. So what this means, we will address it in front. So now, basics of diagrammatic presentation. We have the concept of diagrammatic presentation. This is a technique of presenting numerical data through pictograms, cartograms. I can assure you anything I say we're going to cover it, so don't let any technical term leave you confused or concerned. So bar diagrams and pie diagrams. It is most attractive and appealing way. And please, anything I'm saying, pay attention, because the ending of the class, we're going to be asking questions based on what we've learned, so that we can confirm that we did not just waste our time here. So it is the most attractive and appealing way to represent statistical data. Diagrams help in visual comparison, and they have a bird's eye view. Under pictograms, we use pictures to present data. For example, if we have to show the production of cars, we can draw cars. Suppose production of cars is 40,000, we can show it by a picture having 4 cars, where 1 car represents 10,000 units. True or false? Have you muted?
True, sir.
So under cartograms, we make use of maps to show the geographical allocation of certain things. Now in bar diagrams, they are rectangular and placed on the same base. Their height represents the magnitude and value of the variable. The width of all the bars and the gaps between the two bars are kept the same. While for pie diagram, the circle that is subdivided or partitioned to show the proportion of various components of the data. So let's look at examples of what we just said. Okay, before we do that, in a nutshell, we can say diagrammatic presentation is a visual representation of numerical data using geometric figures, diagrams, and maps. It translates complex statistical information into a form that is easy to understand, remember, and compare at a glance. The primary goal is not to show precise values, but to review patterns, trends, relationships, and outliers that might be hidden in tabular data. So now, key principle. I'm sure you've heard that a picture is worth more than 1,000 words. Same thing in statistics. A well-designed diagram simplifies complexity and accelerates insight. If you remember, in the last class, I told you about a series I watched where a guy in a court case used, even though they were not diagrams, but he used like cards to represent an issue they were facing, So, like they mentioned here, a well-designed diagram simplifies complexity and accelerates insight into whatever challenge they are facing. So now, let's look at pictograms. Looking at this first example on the left-hand side, what fruit can we say is the least most consumed in this area, and why?
Grapes.
So why?
Grapes.
Because it has one.
But it only has one.
One. So
Grapes.
what is the second least most consumed fruit?
Apple. Apple.
So why is the apple?
Because you only have, because it has 5.
Three.
Somebody said 5. Where did you see 5 apples in this pictogram?
3 apples.
I beg you.
Okay.
So let's look at this other example. If one human being represents 10 people, and these people are going to participate in a sport, so which country are we going to say has the most amount of people representing them, and what number did they send to this competition? Oh yeah.
Oranges.
Germany.
Yeah, not just the country, like what number of people did they send?
Germany with 90 people.
90
Okay,
people.
so how did you arrive at 90? Because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So which country sent the second least, like the second to the last most? No, let me rephrase my question. Which country has the least, not the
Spain.
least, but second to
Portugal.
the least representation?
Spain.
So how many people did they send? 30 people. That's actually correct. So let's look at another example. Please, everybody, mute. After you answer question, you mute yourself. So now, if one person represents 1 billion people, what year can we say has the least amount of people in the history of this using this pictogram?
1804.
1804. Why? Because there's only one person here, meaning we're about 1 billion people in the world by that time. So at what point can you say we reach the midpoint from 1804 to 2011? What point are you going to say we reach the midpoint?
2011.
Sorry, maybe I should rephrase my question. At what point can we say we reach the midpoint?
1974.
Why 1974?
1974.
Please mute your mic so I don't have to mute everybody. So that's not really the answer. You can rephrase it in a better way. At what point can we say we reach the midpoint of the population growth between 1804 and 2011?
1974, because it's between if you have to divide it, it's in
It's
between those.
between 7 and 1.
Sorry, somebody said something now. Somebody said something now. What did you say?
It's between 7 and 1.
No, that cannot be the answer now. Like, what year can you say we reach the midpoint of the population growth?
Because
Anyway,
it's the half of it.
you have
Because
tried.
it's half.
You have tried. Let me just give the answer.
Because on the half mark.
Now pay attention. So if you notice, in 1804 we had 1 billion people, and in 2011 we have what? 7 billion, right? 1, 2, 3, 4, 5, 6, 7. So what is the midpoint between 7 billion and 1 billion? That's 3.5 billion. So if you are saying 1974, you are wrong, because 1974 is 4 billion, which is above 3.5 billion. So the midpoint is in between 1960 and 1974. That's the correct answer. Do you understand?
No,
Okay.
sir.
So
Yes,
I'll go over that again. So if there were 1 billion people in the world in 1804 and there are 7 billion people in 2011, the midpoint between 7 billion and 1 billion is 3.5 billion. So for those that say 1974, because if you check it, 1974 looks like the middle. You get, because it looks like, but it's not the perfect middle, because if you notice, since 3.5 billion would be the median point between 2011 and 1804, that means the midpoint lies between 1960 and 1974. Because remember, my question, I did not specify that maybe it has to be a particular year. I just said what point. So the point is in between 1960 and 1974, because that's where you get 3.5. So I think that's actually self-explanatory. So let's look at this other pictogram that shows students' favorite soft drink. So if one bottle represents 2 students, how many students took black currant?
1.5.
3.
1.5.
Three.
He's saying 1 and the half. Don't just rush and answer now. Look, I've been
Three.
passing my screen. 3
No,
students
no.
is correct now.
That's 2 and a half.
3 students is
Oh,
correct. So
three.
let me show you how they arrived at 3, so that you can see
Yeah,
you're just
yeah.
doing guesswork here. So if this represents 2, a full bottle, that means half a bottle represents 1. So when I ask that how many people took black currant, it's obvious that since
That's 3.
represents 2 and half a bottle represents 1, that's 3. So just to test before we move forward, how many people took other drinks?
7.
7, because we
7.
have 3, which will be 2 times 3, 6, plus half, which is 7. So
That's
that's
7.
correct. So now let's move on to cartograms. So cartograms, we have already described what it was earlier. That's when we use maps. So let's look at this cartogram. Comprising of different cartogram types. The more filled bubbles they are, the better. So let's look at this. This is a continuous cartogram. This grid/style cartograms. This is what is known as dulling cartograms. And this is what? Geographical map. So if you look at all of this, let's look at their characteristics. When it comes to easy recognition by position, this one has 2 bars. This one has 1 bar. This one is very hard. So that's why no bar is there at all. Why geographical map has 3 bars? Because it is everything is clear and well itemized. Then for easy recognition by size, this is empty, this is empty. For geographical map, it is also filled with 3 bars, and so on and so forth. You can just look at the rest. Now, for accuracy, this is close, this is also close, but this is very, very close because everything is duly itemized with circles for whatever you're representing. So if this one is looking too technical, let's look at another example. Now, let's look at another cartogram. This has to do with percentage of adults with AIDS in 2008. So for those of you that know your map very well, if blue, like this deep blue, represents better, meaning people that are not infected, and if this dark shade of red represents like adverse cases of people that are infected, what continent can we say has a very bad case of infection of AIDS in 2008?
Sub-Saharan Africa.
Sub-Saharan
So that's actually correct. So which one can we say is in the middle?
Latin America.
Latin America.
Latin America and Middle East and North Africa.
Latin America, Eastern Europe and Central Asia. I wonder why we didn't say that. This is it now. Eastern Europe and Central Africa, and we have parts of North America. So as you can see, it's actually not so hard after all. So let's move on to bar diagrams. So as you can see, bar diagrams, there's always space in between. So now, please everybody mute your mic. You only unmute when you want to answer questions. So now if you look at this very well, the yellow represents 2013 compared to the green, which represents what? 2021. And on the left-hand side, these parameters represent what? Population in millions. So this is 45 million, this is 90 million, and so on and so forth. Then on the x-axis, we have the countries. So if you look at these countries very well, which country can you say has the least amount of proportion of population, both in 2013 and 2021?
Croatia.
Croatia.
That's actually correct.
Yeah.
Now, let's ask the question another way. Which 2 countries have the closest correlation in population? Which 2 countries have the closest?
Tunisia and Portugal.
Italy, France.
You said Tunisia, okay, there's no Tunisia here.
France
Spain.
and Italy. France and
Italy,
Italy.
right? No, Italy and France.
That's actually correct. It's actually Italy and France. But do you know it's not only Italy and France? You can actually find another one. Which other one is
Spain and
close?
Poland.
Spain and Poland.
That's actually correct.
Poland and Spain.
Then the next closest one will be which one?
Croatia and Portugal.
That's actually correct. That's actually correct. You guys should clap for yourself. You did a very nice job. So now let's look at favorite color. And on the left-hand side, we have what? Children. And on the right-hand side, and on the x-axis, we have colors. So which color can we say is the second most liked color?
Red.
Red. Why? Why is it red?
Because he has 8 children, while yellow has between 8 and 10.
That's actually correct. So what is the least liked color and why?
Green.
Green.
Because he has between 3 and 4.
Because it has 3 and 4, okay.
Between 4 and
6 and 4.
Which is 5.
4.
So, and 5 is the least number of children on this bar diagram. So that's actually correct. So let's look at this last one. We have our x-axis as what? Ranges of years between 15 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and 70 years and above. So if you look at this thing very well, what year can we say has the least occurrence in frequency?
70 and above.
70 years and above.
70 years.
That's
70
actually,
years and above.
so that's actually the answer. So let's move on. Now, this chart shows us students who own a smartphone at Redwood School by gender from 2012 to 2019. So, there's a way I ask this question that will be kind of very hard, and I just want us to just do something that will not take time. If you look at, let's do it this way, and please take notes. I actually don't have a note with me here, so let me open a note on my phone. So we'll do one little experiment now. So looking at the first year, who can we say has more phones, boy or girls?
Boys.
Boy.
Boys, right? So,
Yes.
Yes.
so what about the next year? Who has more phones?
Boys.
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 What about the next year? Who has more phones?
Boys.
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 What about the next year? Who has more phones?
Girls.
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 Yeah, I see girls are happy that they now have more phones.
Girls.
What about 2016?
Boys.
Boys.
Please, so who are those ones making noise there? What about 2017? Who has more phones?
Girls.
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 What about 2018? Who has more phones?
Boys.
Boys.
What about 2019? Who has more phones?
Girls.
Boys.
Girls.
So what did you notice about what we said? It would seem that, or let me not jump into the answer. What did you notice about our experiment?
Boys have had more phones than girls, according to the child.
And that's just looking at the bar chart. But do you agree with me that there is a number girls will have in some years that if you look at it in total, they might actually
Yes.
be the one with more phones. So let us now do a more detailed observation on the table so that we can be sure we have the right data. So if we look at boys in 2012, we can say they have about 100 and let's say 10 phones. Then the girls have how many? About 90.
80.
Let's just say 90. So in
90.
2013, the boys have about 190 and the girls have about 180. So in 2014, the boys have about 240 and the girls have about 230. You can be doing the other years before I get there. In 2015, you can say the boys had how many? About let's say 350. And the girls had what? 370. Now in 2016, the boys have about 300. And the girls have about, wait, sorry. 2015 is 250. Sorry. You see, now why they should also deal with me, not why the girls have 270. As for 2016, the boys have about 300 and the girls have about let's say 250. Now in 2017, the boys have about let's say 305. Or let's just say 310. While the girls have 320. Now in 2018, the boys have about 320, while the girls have about 310. While in 2019, the boys have about 320 again, while the girls have 330. So now let's sum. Let's sum it. let's sum it. So for the boys, we have 110 plus 190 plus 240 plus 250 plus 300 plus 310 plus 320 plus 320, which will give you 2040. So let's check for the girls. For the girls, we have 90 plus 180 plus 230 plus 270 plus 250 plus 320 plus 310 plus 330. So that's about 1,980. So since the boys are 2,040, the boys have more smartphones, but the difference is not much. It's just about by a number of 50. So that's the beauty of diagrammatic representation. It gives you more insights. So now let's look at pie diagrams. Out of all the games that are here, I know I've played Monopoly. I've never played Candyland. I don't even know what that is. I've played Jenga, chess. I also don't know what Twister is. I've played poker. And even though I've not played Uno, at least I've seen videos of people playing it. So if you look at this pie diagram, what is the least played game here?
Uno.
Oh no.
Uno. Why is it
No,
Uno?
no,
That's the least percentage.
because it has
That's
4%.
that's the least percent.
So what is the most played game here?
Candyland.
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 Candyland. So as you can see, pie diagram makes it very easy for us to just spot. So now, for those of you, please mute your mic once you're done talking. For those of you that are into comic books, hello, mute your mic, oh, everybody. So now, for those of you that are into superheroes, movies, and comics and all that, so looking at this, who can we say have won more battles among the 1, 2, 3, 4 superheroes that are here?
Batman.
Superman.
Who's that Superman?
Batman.
Are you saying Superman because you're a Superman fan, Abi? Are you looking at that data?
Batman.
The person don't
That
even look at
is
the screen, just
Batman.
say Superman. So imagine Batman, no, that is just using hand to fight is even more than Superman, which I don't know how that's possible, but well, according to our pie diagram, the answer is actually Batman. Interestingly, if we go back, I think Superman is even the least superhero battle winner. And we all know that in the comics, really, he will actually make a quick work of all these guys, but that's another story for another day. So now let's look at this other one. If pink is for apples, blue is for banana, green is for cucumber, yellow is for lettuce, orange is for pears, and this other color that I guess is a shade of green, or I don't even know, like gray, I don't know, blue or something for tomatoes. What can we say is the second most consumed?
That's ash.
Oh, okay. I know ladies, we know the color. They're the ones that used to have cockroach brown, crocodile red, dragon yellow. So which one is the least most consumed fruit according to this pie diagram?
Cucumber.
11.8.
Cucumber.
That's cucumber.
What about the most consumed fruit?
Bananas.
That's banana.
Banana. Yeah.
Banana.
Yeah. So that's actually correct.
Banana.
Or like they will say in group, banana. I'll be able to just mean say that thing. So now, if you look at these streaming services, I wonder why they didn't add pirates here, because pirates has really shown these guys a tough time, especially in third world countries. But anyway, what is the least used streaming service here?
Disney.
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 Right? So
Disney
what about
Plus.
the most streamed service? Movie box.
Netflix.
That's Netflix.
Netflix.
Netflix. Are you sure it's Netflix?
Yes,
Yes.
Netflix.
Yes,
What
that's
is
34%.
Yes.
what is the second most used service?
Other.
YouTube.
Who said YouTube?
Others.
Are you looking at this pie diagram at all?
Others.
Hope it's
Video
not
phone.
audio Zoom you are using. No, use the video one so that I can see what we are looking at. So the second most consumed is which one? Other.
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 Like I said,
Other.
this other is most likely pirated. People that will just go to one website and they can watch all of them in one place. So let's move on. General guidelines. And we'll still come back to this because there is something on this in front. But for now, the general overview. Title. Every diagram must be given a suitable title, which should be small and self-explanatory. Size. The size of the diagram should be appropriate, e.g., that is neither too small nor too big. Paper use. Diagrams are generally prepared on a blank paper, but you and I both know that in the time and age we are in, you can hardly even see anybody using paper. But that's why I said we'll come back to these guidelines later. But for now, this is just like a general overview. Now, scale. Under one-dimensional diagrams, especially bar diagram, the y-axis is more important from the point of view of decision of scale because it represents magnitude along this axis. Whether you agree with this is open for discussion. Now, index. When two or more variables are presented and different types of line shading patterns are used to distinguish, an index must be given to show their details. Now, selection of proper type of diagram. It's very important to select the correct type of diagram to represent data effectively. This point will be better buttressed as we move on. Now, advantages of diagrammatic presentation. Diagrams are attractive and impressive. The data presented in the form of diagrams can attract the attention of even a common man. True or false?
True.
Now, you see this point. There's a place we'll get to. You will understand this point better about diagrams needing to be attractive and impressive. Now, they must be easy to remember. Diagrams have a great memorizing effect. The picture created in mind by the diagrams lasts much longer than those created by figures presented through the tabular forms. I remember watching one, you know what TED Talk is now? You know what a TED Talk is? So I remember watching one TED Talk and one man was talking about Mind Palace. I don't know if it's even called Mind Palace or Memory Palace, but just to show them an example of how powerful Memory Palace is, he gave one very crazy intro about, for those of you that know Sesame Street, but I don't know if you guys actually watch Sesame Street because they used to show it many years ago, but there's this guy they call Cookie Monster in Sesame
We do.
Street. Okay, thank God you do. So he gave one analogy of Cookie Monster sitting on the fridge, eating maybe banana and all that. Like something very crazy, and he went on to say other things that are correlated with that Cookie Monster. And I kid you not, eventually, when he had gone down the rabbit hole and said so many crazy things, he now said, who was sitting on the fridge, something like that. And everybody in the crowd shouted Cookie Monster because of the way he should I say, painted a graphical picture in their mind. It was easy for them to recollect what he said in the beginning, even long after he had said it. But he now gave another example where he just listed things. And when he now said, okay, what was the first thing I said, something like that, they could not answer because the way the mind works, it's very easy for the mind to join things it already knows with things it's just knowing. And also, by not rush this point, because people already know what Cookie Monster was before Infinite Man came, by the time he used Cookie Monster that they related with, by the time he referenced what the Cookie Monster was holding, which is like a new information based on what he was describing, they could remember because they had already painted the picture of that Cookie Monster holding that in their mind when he started. But when he now did something similar, but just repeating it blatantly without any graphical annotation connected to it, where he just listed maybe phone, cow, fish, goats. By the time he got to the end, he said, what was the first thing I said? Nobody could remember. So that's the power of diagrams and the ability to make you remember. And that's why even when you're trying to remember something, let's say you're reading for an exam, your ability to connect what you're trying to learn with something you already know will make it easier for you to recollect. So take note of that. So now, 3, diagrams save time. They present complex mass data in a simplified manner. The data presented in the form of diagrams can be understood by the user very quickly. If you remember when we were using pictograms, it was very easy for you to say, oh, these are the number of people that represented the country, and this is the number of fruits that is the least eaten, and so on and so forth. Now, diagrams simplify data. Diagrams are used to represent a huge mass of complex data in a simplified and intelligible form, which is easy to understand. If you remember, even when we were talking about 1 billion, 2 billion, and so on and so forth, by the time I told you, oh, what is the midpoint of the population growth, it was easy for you to say, oh, it's in between so year and so year, because even though they were in billions, with just one person, we're able to use one person to represent 1 billion. Now, diagrams are useful in making comparison. It becomes easier to compare two sets of data visually by presenting them through diagrams. Then more informative, diagrams not only depict the characteristics of data, but they also bring out other hidden facts and relations which are not possible from the classified and tabulated data. You will appreciate this point when we go into some very technical diagrams later. So now, disadvantage of diagrammatic presentation, lack of precision. They show approximate values, not exact figures. Always supplement with a table for detail. 2, limited data. They can become cluttered and ineffective with very large or complex data sets. 3, mix of misrepresentation. Poor design or inappropriate chart type can mislead or distort the message, e.g. truncated axis. 4, supplementary tool. Diagrams are a derivative of tabulated data, not a substitute for it. Meaning what? As much as you want to use diagrams, it's always good to complement them with tables also. So it's not a diagram versus table kind of war. No, you use them interchangeably to suit whatever outcomes you're trying to accomplish. So now, types of one-dimensional diagram. That's the diagrams that vary only in length. One-dimensional diagram is a diagram in which only the length of the diagram is considered. It can be drawn in the form of a line or various types of bars. The following are types of one-dimensional diagram. 1, we have simple bar diagram. Simple bar diagram consists of a group of rectangular bars of equal width for each class or category of data. This is an example of a simple bar diagram under one-dimensional diagram. Now, multiple bar diagram. This diagram is used when we have to make a comparison between two or more variables like income, expenditure, import and export for different years, marks obtained in different subjects in different classes, etc. So in this case now, this dark blue is what? SOAP 1. This lighter blue is what? SOAP 2. And the lightest blue here is what? SOAP 3. And from April, May, and June, they can compare them in quarterly sales in units. So if you look at this in very well, okay, I wish the colors were more distinct, but the point is that you get the message why multiple bar is different from single bar. You can compare different, should I say, parameters with each other. So now, subdivided bar diagram. This diagram is constructed by subdividing bars in the ratio of various components. So instead of putting them side by side, as you can see, the highest point will be the highest point. All you just have to do is to divide them to correspond with the point on the y-axis. So this is what is known as a subdivided bar diagram. We are still working with SOAPs, but instead of putting them side by side, we are representing them with subdivided points on each bar. So this is what is known as a subdivided bar diagram. Now, percentage bar diagram. The subdivided bar diagram presented on a percentage basis is known as the percentage bar diagram. So this does justice, but this is a perfect representation of what I just read here. Subdivided bar diagram presents, because if you look at this, it's also a subdivided bar diagram. But why this is a percentage bar diagram and not just an ordinary subdivided bar diagram is that this time we're using percentage to represent. So as you can see, okay, let me now ask you this way. If you look at this scale, support, sales, marketing, and development, which one will you say has the most satisfied number of users? And why?
Marketing has the most.
Marketing has
Right?
the most satisfied number of users.
Exactly. And although I wish you said more, but let me just add more context. Because if you actually look at, satisfaction is not just very satisfied. Both satisfied and very satisfied equals satisfaction. So if you look at the bar, both the light green and darker green, you realize that marketing actually has the most satisfied people when you combine the two. So that's correct. Now, broken scale bar diagram. This diagram is used when the value of one observation is very high as compared to the other. To gain space for the smaller bars of the series, the larger bars may be broken, and the value of each bar is written at the top of the bar. So this is a mistake. This is not an example of a broken bar. This is a mistake. I just hope I corrected it. Okay, so the corrected bar is not written here. This is representative of percentage bar. So this is a mistake. But we'll look at an example now that will explain what I just described here. Don't forget, a broken scale bar diagram is a diagram used when the value of one observation is very high compared to the other. So let's look at this example. So if you look at this example, in 2005, we had exports of 150. In 2006, we have export of 300. In 2007, we have export of 3,550, which is very large. In 2008, we have export of 550. And in 2009, we have export of 450. So now, let's look at the solution. So if you notice, in 2007, we had 3,550, which is significantly higher than the others. So what do we now do in this case? You and I both know that if you want to show the 3,550 on this y-axis, it will consume a lot of space because we have 100, 200, 300, 400. If I'm not mistaken, the least highest before the highest is 550. So since you have 550, if we want to show where 3,050 is on this scale, it will be very large. But that's the beauty of where a broken scale bar diagram comes in. Because in a broken scale diagram, all you have to do is just to use this line to signify that, oh, even though there are other scales in between here, we're going to jump to the next scale that we need. So that's why you can see here is circled and it's called breaking scale. And now we will also break this to show you that, see, there was a breaking scale, but at this point, this is 3,550. So from this, you can still determine that, 2007 was the year where we had the highest number of imports. But we can now also capture, export. But we can also capture that export on the y-axis without having to draw with the same scale. Because if you check it, there's always a scale of 100, 100, 200, 300, like that's supposed to be the scale. But now we jump to 3,500. So this is what we use to signify that, there's a jump that took place here so that there won't be confusion. So that's a broken scale bar diagram. Now, the next one is what? Deviation bar diagram, which represents net values, positive and negative, like profit, loss, trade surplus and deficit, and bars extend on either side of a zero line. So let's look at this example. This refers to net exports and the X as it represents to year. So if you look at this very well, you realize that in 2015, they exported 200. While in 2016, they imported about 120 and so on and so forth. 2017, 150, 2018, 60, and 2019, they imported 100. So let's look at the example that has to do with profit, sales and profit. So in 1985, they sold, I love this example so much. In 1985 to 1986, they sold about 10% sales and made profit of about 50%. While in 1986 to 1987, even though they sold about 14%, which is a little bit higher than what they sold in 1985 to 1986, what can you notice about 1986 and 1987 compared to 1985 to 1986?
They made loss of about 20%.
They made a loss of 20%. So who knows, maybe that's what influenced them to now sell less in 1917 to 1988, which helped them cut their loss to 10%. So that's the beauty of deviation bar diagram. I'm sure for some of you are just hearing about some of these things. So now let's move on to two-dimensional diagram, which vary in both length and breadth and represent area. So we have rectangles, which is used when two variables, e.g. length and breadth, need to be represented simultaneously. So in this case, you can see they say calculate the perimeter of each rectangle by adding the length and width together and multiplying by 2, which is what they did here. But we've already worked with rectangles in math, so I shouldn't dwell too much here. Now, for squares, they compare magnitude by area of squares. I don't know if you have seen all these redos where they'll say how many squares are in this picture. So in this case, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's still one square here, making 10. There's another square here, making 11. There's another square here, making 12. Another square here, making 13. I don't know, is that all? Okay, and I think there's a general square making 14. So I don't know if I'm correct. I think there are about 14 squares here. So now, another types of, and okay, another one too, we have circles and pie charts, which we have already covered before, so I will not take too much time here, which is ideal for showing proportion. The circle represents the total and segment slices show the percentage share of components for multiple totals. Vary the area of circles proportionally. So we've already looked at these examples before on that pie diagram. So as you can see, they're also called circles and pie charts. Now, for three-dimensional diagrams, they vary in length, breadth, and height. So we have cubes, spheres, frustum, and so on and so forth. We compare magnitude by their volume, less common as volume is harder to judge, visually than length or area. And that's actually true. If you look at a rectangle now, visually it's very easy for you to look at the length and breadth and say, okay, this is longer or shorter and so on and so forth. But volume is almost impossible to tell just by looking at a picture. You get, because picture is 2D, it's flat, and volume is something that requires not just length and breadth, but height and space and so on and so forth, weight and so on and so forth. So as you can see, these are different shapes that can be used to represent volume: sphere, cylinder, cone, and so on, rectangular prism and triangular prism. So now, specialized statistical charts. We have histogram, a bar chart for continuous group data, where the bars touch each other, which we've mentioned before, and the area represents frequency. So as you can see, this is a histogram, but we will now move on to show different types of histogram. We have the one that is skewed left, we have the one that is skewed right, we have the one that is symmetric and unimodal, we have the one that is uniform, we have the one that is bimodal, meaning about 2 horns, and we have the one that is multimodal, which can have more than 1 or 2 and 3 and so on and so forth. We also have frequency polygon, which is a line graph drawn using midpoints of histogram class intervals. You see these histograms. Please just give me some time. So I'm sorry, I had to attend to something. So like I was saying, if you mark the midpoint of the histogram and you connect it, you will get the frequency polygon. So as you can see, this is an example of doing just that here. So now, ogive is what? Also known as the cumulative frequency curve, and it shows cumulative totals, which can be less than or more than, depending on what type you are looking at. So this is an example of a cumulative frequency curve. And if you look at this example, you can see one is slanting to like it's slanting from top to bottom, and one is going from top to bottom. One is going from top to bottom, but other one is going from bottom to top. So the one that is going from bottom to top, that is represented by this green line, is less than the ogive, while the one that is going from the top to the bottom is more than the ogive. So now, another example is what? Line diagram / time series graph, which is essential for showing trends over time. And it helps to plot data points connected by lines. It plots data points connected by lines. So as you can see, there are a lot of lines here, each distinct color representing a year, which is on the left-hand side, while the x-axis are months. So now another one is what? Scatter plot, which shows the relationship in bracket correlation between 2 quantitative variables. So when it is facing the right-hand side, we say it is positive and linear. When it is facing the left-hand side, we say it's negative and linear. When it's slanty like this, we say it's negative non-linear. And when it's just scattered like this, we say it has no relationship. Now, if you look at this example now, it's almost looking like no relationship, but there's actually a relationship. Because if you look at it very well, it is using this line, you can see that it is what? Positive and linear. While if you look at this other example too, this one is what? Strong positive linear, meaning there can be strong, there can be moderate, because this one now is negative linear, but it's moderate. While this one is what? No relationship. While this one is what? Strong non-linear. So using this here, what can we call this one? This one on the left hand side. I don't agree that it's strong positive linear. Another person should try.
Moderate.
Thank you, but that's not it. I need the full answer. You can't just say
Moderate negative linear.
negative linear. Okay.
Moderate positive
No,
linear.
moderate positive linear.
Positive linear. It's moderate positive linear. So now we look at box plots, also known as whisker plots, which summarizes data distribution showing median, quartiles, and potential outliers. In a box plot, the whiskers are lines extending from the box, the middle 50% of the data to show the range of the remaining data, indicating variability and identifying potential outliers, with shorter whiskers, meaning data is closer together, and longer whiskers showing more spread, helping to visualize data distribution and skewness quickly. So we have upper extreme, we have this part known as the upper quarter, we have the median, we have this part known as the lower quarter, we have here also known as the whisker, we have here known as the lower extreme, and we have our outlier single data point. So all of this now, let's look at it in action. If we use a normal distribution, you can see that the part that responds to the median actually corresponds with the middle of the data set. While these other points that they call outliers are these other purple points you're seeing here. And this angle here is what is known as what the whisker, here and here. So this part is what? Depending on where you're looking at it from, there's the upper quarter and there's the lower quarter. So this is the upper quarter because this is 0 and this is 1. So this is the upper quarter, while this is -1. So this is the lower quarter. So this represents what? This line represents what? The upper extreme, while this other line represents what? The lower extreme. So this is what box plot is all about. So now, if you remember, I told you we were going to go to guidelines for constructing diagrammatic presentation. Initially we looked at the general one. So now let's look at the guideline for effective diagrammatic presentation. So choose the right chart. Let your message guide the format. Comparison you should use bar for comparison, you should use line for trend, and you should use pie chart for composition. Now, you should have clear title and labels. Every diagram must have a self-explanatory title, and the axis must be clearly labeled with units. Scale and proportion. Use a consistent and honest scale. Start the vertical axis at 0 to avoid distortion. Legend and keys. Use them to explain colors, patterns, or symbols. Now, simplicity is key. Avoid chart junk. This we will soon address so that you will understand why we avoid it. What is chart junk? Excessive grid lines, decorations, or 3D effects that obscure the data. Like I said, we'll soon look at why we must avoid this. Now, source and data reference. Always cite the source of the data. Always. Now, what is chart junk? The term chart junk was coined by Edward Tufte, who considers anything in a chart that does not represent data or is a scale or label as not just unnecessary but harmful. A related term is the data to ink ratio, which is a term to describe how many visual items, how much ink representing data there are in a chart in relation to how much there is overall. The idea is to keep that ratio as high as possible, thereby producing very minimalist looking charts that focus entirely on the data. There is almost universal agreement that any extraneous elements in a chart or visualization elements do not represent numbers are detrimental to understanding the data, so that you can have a better understanding of what chart junk is all about and why we avoid it. Let us look at some examples. So these are some examples of chart junk. If you look at this thing now, I'm sure one of the first things that comes to your mind is not data. You are probably looking at this monster and you're wondering that, what is with this big mouth and all that? So you're already losing sight of what you should actually be paying attention to. So this is actually what talking about total house and Senate campaign expenditure in millions. But the messages that is supposed to be passed is almost lost on the platform they are using to pass it. This other one now is what? Average price of a 1 carat, the flawless diamond or whatever. But now they are putting a woman in a very funny position, and I don't know. This is just chart junk at its highest. So these are examples of chart junk. Let's look at some other examples. This is supposed to be, I don't know, a trend line or what, but it's just the color scheme, the color tone and everything is just out of place. As you can see, they are putting months, they are putting region. It's just like it's just something else. Now look at another one again. Crashes by OS version normalized. You see this thing now that is just juxtaposed with all kind of information. It loses the value of what it's trying to pass across, because when somebody sees this, one of the first things that comes to the person's mind is that, is there no better way of doing this? Why is it looking this way? Now look at another one. If I'm not mistaken, this has to do with proportion of consumption met by recycled materials. But there are so many things that are crammed into this place that it doesn't help matters at all. Doesn't help matters at all. Whatever they hoped to achieve by cramming all of this into this small space, it's almost like good intention but bad output. This is another example of chat junk. As you can see, ticket sales on the web take off. Total dollars spent on the web for travel reservations. In 2001, 7.44 billion was spent. 2001, but as you can see, the bars are represented with dollars. The background is represented with so many pictures. The color scheme is just at war with each other. And crazily, the years are shown on the y-axis instead of on the x-axis. So I hope people are getting an idea of why chat junk is what it is and why it is frowned upon, because these are some examples to show you why you don't use chat junk when you are presenting data. This is also another example of chat junk. That's on the left-hand side. You can see that this person tried to use dollar notes to represent this minimum wage. While the other one, which is a good presentation, make use of what we are used to. This time, I think he used a live graph where it's showing the same thing, but it's just minimalist in nature and addresses this point. So this, you should do more of this and less of this. So now let's look at a modern context for data visualization. The diagrammatic presentation has evolved into the powerful field of data visualization using software like Excel, Tableau, Power BI, etc. to create interactive and dynamic dashboards. The core principles, however, remain the same: clarity, accuracy, and efficiency in communication. If you remember, when we're looking at that general guideline for diagrammatic presentation, what did I tell you? Sorry, what was one of the things that we saw that I told you we are going to come back to? They said something about that diagrams are done on paper and all that. And I told you that we'll reach a place where we'll come back to that. So now in the world we're in, we have things like Microsoft Excel, which is a powerful spreadsheet software for organizing, analyzing, and visualizing data using grids of cells, offering features like formulas, charts, pivot tables, and AI assistants, Copilot. Available on desktop, mobile, online for tasks from personal budget to complex business finance. It is part of the... So my point is, this does not use paper at all. Fine, whatever result you get, you might end up printing it on a paper, but we have gone past the days where, more emphasis was placed on writing on paper. Now you have things like Microsoft Excel, you have Tableau, which is also a visual analytics platform that transforms the way we use data to solve problems. And we also have Microsoft Power BI, which is also a powerful interactive business intelligence platform that turns raw data from various sources into actionable insights. So fine, you can print it out on paper, but it's not compulsory. You can also visualize it in a projector and so on and so forth. So that general guideline that I was saying something about paper, in the time and age we're in, you can work with so many, it's not compulsory you work with paper. You can actually project your diagrams on so many mediums. So now let's start looking at questions. So I expect people to start answering now. Why is the diagrammatic presentation better than tabulation of data?
Because it's easier to understand.
Okay, another
It
person.
gives more details of what exactly we
It
are doing.
saves time.
Okay, try and make sure one person finish before you answer. Okay, you say it takes time. It takes time, K.
It saves
Saves
time.
time.
No,
Saves
time. Okay. Okay, one last person before we look at the answer.
It's more
It is
explanation.
very easy to remember.
Okay, it's very easy to remember. So let's now look at the
Easy
answer.
to compare.
Yeah, so you've all tried. Let's look at the answer. So now, for the short answer, diagrammatic presentation is not inherently better. So that's like a trick, like a trap. The word is not necessarily better because tabulation also has its strength, but it has a different complementary purpose. It excels in visual communication, pattern recognition, and quick comprehension, which are some of the things you guys have already alluded to. While tabulation excels in what? Precision, detailed analysis, and data storage. So now let's look at a more detailed answer. For communication and understanding, faster comprehension. The human brain processes visual 60,000 times faster than text. I don't know how true this is, but I know that images are faster for us to comprehend than just text. And diagrams allow audiences to grasp the main message in seconds. Better memory retention, like one of you already pointed out. Visual patterns create stronger meta impressions than columns of numbers. People remember charts much longer than tables. Immediate pattern recognition. Trends, comparisons, proportions, and outliers become immediately obvious in diagrams, but require careful scanning in tables. Now, for revealing insights, visual storytelling. Diagrams tell a data story at a glance. A line chart immediately shows growth trends. A pie chart instantly reveals market share distribution. Relationship highlighting. Diagrams excel at showing correlations, scatter plots, path to whole relationship pie charts, and comparison bar charts that require mental calculation in tables. Emotional impact. Well-designed diagrams are more engaging and persuasive, making them superior for presentations and reports meant to influence decisions. 3, for specific audience and purposes. Executive/management use. Senior decision makers need quick insights, not raw data. Diagrams provide the big picture efficiently. Public communication. Diagrams make statistics accessible to non-experts and help overcome statistical illiteracy. Comparative analysis. When comparing multiple categories or time periods, visual comparison is more effective than reading numbers. Now, practical advantages. Space efficiency. A single chart can summarize information that require multiple tables. That's actually very true. Presentation readiness. Diagrams are presentation ready. Visual aids that require minimal explanation. Universal understanding. Visual language transcends literacy and language barriers better than numerical tables. You and I both know that, for example, in that pictogram, someone that might have issue with tables, once he sees, all those fruits and sees that the grape was only one, it's easy for that person to say that this grape is the least occurring fruit here. Now, of course, he can see the picture and his mind can easily understand that. Now, note, however, it's crucial to know that diagrammatic presentation is not universally better. Tabulation has its distinct advantages. For example, in precision, table shows exact values, diagrams show approximations. Detail, tables can handle large data sets with many variables. Analysis, statistical calculations require tabulated data. And verification, tables allow for fact-checking and detailed scrutiny. Now, conclusion, diagrammatic presentation is better when the goal is quick understanding, pattern recognition, effective communication, or persuasive presentation. Tabulation is better when the goal is detailed analysis, precise reference, data storage, or complex calculations. The most effective statistical communication uses both. That's tables for detailed record and diagrams for a compelling story. So let's look at our next question. Why do media persons prefer diagrammatic presentation of data?
Because it's easier to present.
Okay, another person.
Because it's easier for remembrance.
It's like if I just repeating what I said before. But yeah, one last person.
The students, the viewers can understand it better.
Okay, this one is only men that are talking. What happened to all those ladies that were answering for? Okay, it's easier to comprehend. One last person, one last lady.
It's fun when answering the question.
Is what?
I said it's fun when answering the question.
That's why media persons prefer diagrammatic presentation of data. I should not answer another question. You say it's fun when you're answering the question. How is that the question I'm asking? Anyway, let's look at the answer. At least you made an attempt. So, short answer, media professionals prefer diagrammatic presentation because it transforms complex data into compelling visual stories that quickly capture the audience attention. I think one of you alluded to this. It simplifies information for mass consumption and it enhances message retention in an environment of information overload and short attention span. This is so true. Let me just deviate a little bit. I don't know if you are aware that people now have short attention span. So if you are giving them a table with a lot of numbers, that person will most likely scroll away if it's on TikTok or Facebook or whatever. But there is an image will show that person that will capture that same data the table is showing, and the person will be more interested to look at that. So this is so true. So let's look at a detailed answer. Audience engagement and attention economy. Instant capture. In today's fast-paced media landscape, diagrams and infographics can capture attention within 3 to 5 seconds, compared to tables or text that require longer engagement, which is what I just alluded to now. Visual appeal. Colorful, well-designed charts are more likely to be shared on social media, increasing reach and engagement metrics that matter to media outlets, which is also what I just said now. Emotional impact. Visuals can evoke stronger emotional responses than numbers alone, making stories more memorable and impactful. Now, simplification for mass consumption. Democratizing data. Media audiences vary widely in statistical literacy. Diagrams make complex data, e.g. economic indicators, election results, pandemic statistics. If you remember, I don't know if you guys remember during COVID, when there was one image they always released that was showing number of deaths and number of infected people and so on. Do you remember that image? That used to have like black, yellow, and some other colors like that. I don't know if you guys remember that picture that they were always releasing that was keeping count of the number of people that died due to COVID.
Yes, I remember, sir.
So accessible to everyone regardless of education level. So as you can see, regardless of education level, whether you studied in primary school or whether you're a professor, once you see that table that was showing the figures, you could tell whether it was getting really bad or whether it was subsiding and so on and so forth. Now, storytelling efficiency. A single well-designed chart can replace paragraphs of explanatory text, saving valuable space time in newspapers, broadcasts, or online articles. Clarity in complexity. For topics like budget allocations, demographic changes, or scientific trends, diagrams help viewers grasp relationships that will be confusing in tabular form. This is so true. You and I both know that there are some concepts they will bring in maybe rocket science or in aeronautics engineering that if you show a layman in tabular form, person might get lost in all the technical jargon and the numbers and formulas and so on and so forth. But when you put it in diagram form, it's easier for that person to comprehend. Now, communication effectiveness, trend revelation. Line graphs instantly show what's going up and down, like inflation, stock markets, COVID cases, like I mentioned earlier, without requiring the audience to interpret raw numbers. Comparison made easy. Bar charts allow quick comparison between parties, countries, time periods, or products, a common need in news reporting. Now, proportion visualization. Pie charts or stack bars effectively show distributions, election vote share, budget allocation, demographic breakdowns, and so on and so forth, that are central to so many news stories. Production and practical considerations. Space optimization. In print and digital media, space is limited. A diagram conveys more information per square inch than a table. Visual, and this is not just true for only magazines and newspapers. Even when they are presenting on their screen, it's easier for them to just show a diagram that will capture what 10 tables would have taken more space and more time, especially when they have a short time to present what they are presenting. Now, visual variety. It breaks the monotony of text-heavy pages and screens, making the overall presentation more appealing. Brand identity. Consistent visual styles in data presentation, like the New York Times famous chart, become part of media outlets' brand identity and authority. This is talking about how there's a style. I don't know if you have seen this, I think they call it the street church. They always use this yellow and black color of Danfo. Then they'll now use pidgin to write verses of the Bible. I don't know if you've seen that picture on social media. They always release different pictures, but the format is consistent. Yellow and black line, just like Danfo. Then they will now put like a message from the Bible in pidgin. Don't tell me you've not seen. I think the street church is their handle. I don't know if you've seen it before. So that's like their identity. And if somebody else use that same yellow and black line, it look as if they are copying them because they're like the first people to use it. So now, cognitive science advantages. Reduce cognitive load. Diagrams organize information visually, reducing the mental effort needed to understand complex data. Enhance recall. Studies show people remember 65% of visual information, compared to 10% of written information after 3 days. Critical for news retention. Now, pattern recognition. The human brain is wired to recognize visual patterns faster than numerical patterns, making diagrams more effective for quick comprehension. Now, digital and social media dynamics, shareability. Infographics and data visualizations are highly shareable on platforms like Twitter, now known as X, Instagram, and LinkedIn, driving traffic and engagement. Mobile optimization. On small smartphone screens, a clear chart is far more legible and effective than a multi-column table. Interactive potential. Digital media allows for interactive diagrams where users can hover, click, or filter, enhancing engagement beyond static presentations. We also have persuasive power in journalism. Evidence visualization. Diagrams make abstract statistics concrete and believable, e.g. climate change is real, shown through 100-year temperature charts. Bias and emphasis. While potentially problematic, media can use selective diagram design to emphasize particular aspects of a story, scales, color choices, what to include, exclude, and so on and so forth. Credibility establishment. Well-researched, professionally presented data visualizations enhance the perceived credibility of the reporting. Now, important caveats media professionals need to consider when they're using diagrammatic presentation of data. Oversimplification risk. Good journalists balance simplification with accuracy. So you will not sacrifice accuracy because you want to just present data in a simple form, avoiding misleading representation. Because you and I both know that fake news is a serious challenge in today's social media and in journalism in general. Source transparency. Ethical media always cite data sources, even in visual representation. Audience appropriateness. Choice of diagram type depends on the audience and platform. Simple pie chart for TV news, more complex interactive for online. Now, conclusion. Media professionals operate in a quantitative attention economy where they must inform, engage, and persuade diverse audiences quickly. Diagrammatic presentation serves as their most powerful tool to transform abstract data into concrete stories that are immediately understandable, emotionally resonant, and highly shareable, fulfilling both journalistic and business objectives in modern media ecosystems. So now, which bar diagram is used to show two or more characteristics of data?
Multiple bar chart, I think.
Yes, any other person?
Histogram. Histogram.
Any other person before I say the answer?
Histogram.
You say what?
Pie chart.
The answer is actually multiple bar diagram, which is also called group bar diagram, and is used to show two or more characteristics of the data. What is the purpose? To compare two or more different variables across the same categories. What is the structure? For each category on the x-axis, multiple bars are placed side by side, each representing a different characteristics. And what is the visual? Each characteristic has its own distinct color pattern with a legend to identify them. Because since you are looking at multiple representation, you have to make them distinct from each other. If you use the same color, it kind of defeats the whole purpose of distinguishing two different components from each other. I don't know if you remember when we used, we're looking for 3 soaps. What did we use? We used different shades of blue to represent each soap. So, and we had a legend by the side that showed how one color represented soap 1, another color represented soap 2, and so on and so forth. So now, mention the sum of all angles formed at the center of a circle.
360.
360, that's actually correct. So a complete circle represents a full rotation. By definition, one full rotation around the point, the center, measures 360 degrees. Therefore, all angles that originate from the center and partition the circle must collectively sum to 360 degrees. So now, can you name a bar diagram where the height of all the bars is the same? Can you name a bar diagram where the height of all the bars is the same?
Component bar chart.
Any other person? Sorry?
I think it is divided bar chart.
So the answer is percentage bar diagram. So let's look at the definition. A special type of subdivided, if you remember, there's also subdivided bar diagram. But in percentage, they will all be the same height. A special type of subdivided bar diagram. Please hope you remember this subdivided bar diagram that, if you remember, they were asking people that were satisfied, very satisfied, and I told you that marketing department were more satisfied based on what they showed us. You remember that diagram?
Yes, sir.
Fine. What did you notice about that diagram? They all had the same size. The difference was the percentage.
Yes, remember, sir.
The difference was the percentage in between. So a special type of subdivided bar diagram where each bar represents 100% of a total. And components, please, can you mute your mic, please? Represent 100% of a total, and components are shown as percentages of that total. Key feature, all bars have the same total height and length, representing 100%, but their internal subdivisions differ based on the proportional composition. Why do all the bars have equal height? Each bar corresponds to a different category, usually different years, regions, or group. Instead of comparing absolute total, which will give bars of varying height, we compare the relative proportion of components within each total. And since every bar is standardized to 100%, they all have identical heights. So now, which diagram can be used to depict various components of a variable? Please try and answer
Bar chart.
with your head, though, because if you're using AI, it defeats the whole purpose. Because
Bar chart.
in the beginning of the class, I told you that we are going to answer questions based on the class to make sure that you are following. So try and answer. It's
Bar chart.
saying you wrong and you're wrong than for you to use AI and you're right.
Bar chart.
Not learning anything. Any other person?
Pie chart. Bar chart.
So the answer is subdivided bar diagram, which is also called component bar diagram or stacked bar diagram, which is specifically designed to depict various components of a variable. And the purpose is to show both the total value of a variable and the breakdown of its components within each category. Visual structure: a single bar for each category divided into segments where each segment represents a component
have a question
to the total. I'm coming. And the key feature is that it shows part to whole relationship for multiple categories simultaneously. And like I already showed you from the last question, the percentage bar diagram is a type of subdivided bar diagram. What is your question?
And please, what is the difference between a bar diagram and a bar chart?
What is the difference between a bar diagram and a bar chart?
Yes.
And did you join this class late?
No, sir.
You've forgotten that when we looked at bar diagram in the earliest slide, one of the earliest slides, there was a slash now, like bar chart slash bar diagram now. So you can call it bar diagram, you can call it bar chart. So that one is not an issue. So now, what is the multiple bar diagram? Your voice is low. You need to increase your volume. We can't hear you. Whoever was talking, we can't hear you.
It represents at least two variables.
It represents two or more variables or used to show two or more components.
Okay, so
multiple bar diagram represent two or more.
Yes? You are saying something?
It used to represent two or more
No.
components.
One lady was saying something now.
Yes, sir. It used to represent two or more variables or components.
Okay. So a multiple bar diagram, also called group bar diagram, is a type of bar chart used to compare two or more different variables, so you are correct, across the same set of categories by placing their bars side by side for each category. Core concept: to visually compare multiple related variables within and across categories. And for each category on the x-axis, multiple bars are grouped together, each representing a different variable, and using cluster columns to enable easy comparison between variables and across categories. Key characteristics: bars for the same category are placed adjacent to each other. All bars have identical width, different colors, patterns for each variable, and it's space between groups of bars, different categories, but not between bars within the same group, and must include a key identifying what each color and pattern represents. So now, which bar diagram is used to represent the net changes in data?
Loss across.
You say what?
It is the arithmetic line diagram.
Another person?
Cumulative frequency curve.
It is the arithmetic line diagram.
So the answer is actually deviation bar diagram.
Yeah.
Are you sure you've got any of my question for? So what is the purpose of deviation bar diagram?
Yeah.
Specifically designed to represent net changes, gains, loss, surplus. Have you forgotten that one that we used to show profit and loss now? You've forgotten?
So,
You can't remember the name. That one that we showed profit and loss when the person made sales now, 1985, 1986, 1987, 1988, forgotten. Hope you remember now. So
Yes,
it's
sir.
specifically designed to represent net changes in gains, loss, surplus, deficits, positive, negative deviation from a baseline, and the bars extend in two directions from central zero line or baseline, and positive values can go upwards or rightwards, negative values go downwards or leftwards from the reference point. Now, a central reference line represents zero at the starting point, and they extend the opposite direction based on the sign, whether it's positive or negative, and positive in our own example that time was for profit, while the negative was when they made loss, and it clearly shows which items have positive versus when it has negative changes, and they emphasize the size of deviation regardless of direction. Now, profit versus loss, when it's financial, we have to do profit versus loss or budget surplus versus deficit. When we're dealing with trade, usually export surplus versus import deficit. When we're dealing with performance, it has to be above target versus below target performance. And when we're dealing with scientific, we have temperature anomalies above and below average. And when we're talking about survey results, we deal with agreement versus disagreement percentages. The truth is that you see all these things we covered today, you might not need all of it, but as you go on, not just if you in the university, in academia, if when you go on to whether establish your own company, found your own company, or you work in any company, you might come across some of these things, and they will not be new to you again because you would have had like a thorough understanding of what they entail. So that's the beauty of this class. Like you will still come across some of these things in the boardroom, in online surveys, when you are making your own presentation. So that's when you appreciate some of what you've learned here today. So now, what is the other name of subdivided bar diagram?
That's bar charts.
Bar chart,
It is deviation bar diagram.
Components.
I say stacked bar charts.
Components bar diagram.
Okay. So the answer is component bar diagram, which is also commonly called stacked bar diagram or composite bar diagram. So you guys have finally gotten one of my questions. So last but not the least, what will be the degree of an angle in a pie diagram if the family spends 50% of its income on food?
180 degrees.
180.
That's actually correct. That is actually correct. And that was very fast. So this is how you got it to 50 divided by 100 times 360 or 50 times 3.6, which will give you 180 degrees. So we have come to the end of this class.